Hi, I'm Bob Young, Assistant Professor of Mathematics at Brevard Community College. This is Empowering Introductory Algebra, the series created to assist you, the student, to overcome any basic algebra deficiencies and to prepare you for those college-level courses. My excellent support staff of WBCC and I want to help you build a strong algebraic foundation and study skills necessary to excel in the course. Let's continue the adventure. Now, if you remember, we picked up last time, we were working on addition and subtraction of real numbers. We were working on getting those signs straight, and I hope you practice quite a bit and are very proficient in doing those type problems now. So today, what we're going to start with, going to our first graphic, is multiplication and division of any two real numbers. Then the rules here are, if the signs are the same when multiplying or dividing any two real numbers, you'll get a positive result. If the signs are different, negative result. So let's go to some examples and illustrate this. -5 times a -10. Now notice multiplication here using parentheses with nothing in between, so that means multiplication in algebra gives us a positive 50. Now, why positive 50? Why is a negative times a negative positive, Young? Well, remember in the last lesson we talked about the double negative property. So if we wanted to rewrite these negative signs on -5 times -10, we could write that as minus a negative 50. All right, and we remember that minus something negative means the opposite of something negative. Therefore, multiplying two negatives gives us a positive result. So the old double negative property is back again. Thus, whenever you multiply two negatives, positive. All right, going down for the next example, a negative times a positive, different signs. You're going to have a negative result, -7 times 6, -42. -60 divided by a positive 2, different signs, -30. -40 divided by, notice writing division as a fraction here, divided by -8 gives us a positive 5. Again, we could write that as minus a negative, thus giving us a positive answer. Now notice in this case, multiplication, we've got both the dot and the parentheses. Some of you out in the audience from the previous lessons might be saying, hey, what a waste. We don't need both of those symbols, but we have them. And that's going to give us what type of 60? Different signs, -60. And the last one might be a little confusing to you. You might say, what's up with this one, Young? -17 divided by -2. 2 doesn't go into 17 evenly. But the principle here is you don't want this. This is bad syntax in algebra. A negative divided by a negative will yield that positive result. So just write that as a positive 17 halves. And again, since these numbers, nothing goes into 17 or 2, they'll leave the improper fraction in algebra. All right, so let's go back to another graphic here. The next graphic, well, it's nice if you have two numbers, Young, but what if you have more than two? Well, then, if you have strings of positive and negative numbers, an even number of negative signs gives you a positive result, versus the odd number of negative signs gives you the negative result. So let's check a few of these type problems out. So here's a whole bunch of them here. So what we have is -4 times -2 times 5 times -1 times -10. All right, first let's get the signs straight, because again, the signs are the killers in algebra. So we have an even number of negative signs here, 1, 2, 3, 4. Therefore, I know my answer is going to come out positive something. Positive what? Well, just do the multiplication. 4 times 2 is 8, times 5 is 40, times 1 is 40, times 10 is 400. So all of that string of numbers multiplied together would give us a result of positive 400. Next example, we have -3 times -10 times -1 times -2 times -4. Don't let all this scare you. It's just a matter of what kind of answer is it going to be, positive or negative? Well, there's 1, 2, 3, 4, 5, an odd number of signs here. Negative, what? 3 times 10, 30, times 1, 30, times 2, 60, times 4, negative 240. All right, so if there is an even number of negatives, positive result, odd number of negatives, negative result if there's a bunch of them. And we're going to get to this concept a little bit later also. Negative 1 to the 33 power, now this is exponential notation. It means negative 1 multiplied together, and I'm not going to write that out 33 times, but it would be negative 1 times negative 1 times negative 1 times negative, blah, 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 all the way out 33 times. So what answer would that be? All of those ones would be 1 sign, odd number here, negative. Negative. So that is how you deal with these strings of creatures. Okay, let's do some more multiplication and division practice. All right, negative 72 divided by 8, different signs, negative result, negative 9. Okay. Now wait a minute here, 0 divided by negative 2, let's look at this one now. This answer comes out to be 0. And notice this other one here. There's a few tricks they're going to try to get you on. 5 divided by 0. And if you tried this on your calculator at home, it would not like it. If you hit on your calculator 5 divided by 0, it would say error. Say, what are you asking me? That result in algebra is undefined. Whenever you divide by 0, division by 0 is undefined. Now, some of you might want to say, Young, why is division by 0 undefined? Why can't you divide by 0? Let's think about that. Now, I'm kind of an old-fashioned teacher, so I'm going to show you some old-fashioned illustrations here to see if we can show you why something divided by 0 is undefined. Let's go back and look at something here. Now, if I were to take the fraction 6 over 2, which means 6 divided by 2, y'all would tell me 3, right? Now, if I wrote that the old-fashioned way, I could write it as 2 divided by 6 in that manner. Okay, I could say 2 goes into 6 3 times. Now, how could we check that? Well, 3 times 2 is 6, and if you subtract it, you get a remainder of 0. So multiplication would check division here, and that makes sense. Even in this example, 0 divided by negative 2, if we divided the bottom into the top, which is how you would make something into a decimal from earlier lessons, negative 2 goes into 0 0 times. And that would check because if I multiplied this, I would get the number under here, which is called the radicand, or not the radicand, but it's called the dividend. All right, now look at this one, 5 divided by 0. Let's try the bottom into the top here, 0 divided into 5. What number times 0 is ever going to give me a 5? And I know the English or comm teachers isn't going to like this result, but that's how the country folks say it, ain't one. Ain't no number times 0 ever going to give you 5. So that's when you ask your calculator something divided by 0, that's why it spits out error and the result is undefined. No number times 0 will ever give you anything. All right, going to more multiplication and division practice. Now remember when we added and subtracted fractions in the last lesson, we got a common denominator. When we multiply, all we need to do is cross-cancel common factors, or what I like to call chop chop. I mean, we're going to become black belts in math here. We're going to go chop chop, cross-cancel. All right, so what I'm going to do here is look at these problems here. I've got how many negatives here? 1, 2, 3. That's going to give me a negative result. And then I'm going to start cross-canceling. I'm going to go ahead and take the 2 and divide it into 4. 2 goes into 2 once, into 4 twice. No need to get a common denominator here. And on the negative 10, we can make it a fraction by putting a 1 under it. So that's still negative 10. And we can continue the chop, chop, chop. Yeah, so now we can take this 2 we've already cross-canceled and into the 8. So as long as you have a common factor in the top and in the bottom, or in the numerator and denominator, you can cross-cancel, or as Young likes to say, a chop chop. So that gives us 1, 4 now. Now, when we're done here, we can say, hey, this is what's called a partial chop chop. I can't totally take 4 into 10, but there is a common number, and I think y'all know what it is. 2 goes into 4 twice. 2 goes into 10 5 times. So what's left now is going to be the answer multiplying across and bottom. All right, but wait, I see one more chop. I know what some of you are thinking, but Young, how about these 5s? Yes, they will cross cancel as well. So 5 goes into 5 once, that goes into 5 once, and what we're left with is a final answer here of 1 times 1 times 1 times 3 is 3 over 1 times 1 times 1 times 2 is 2 for a negative 3/2. Sometimes I get students when they multiply fractions, they try to just multiply all the tops together, put it over all the bottoms. They get this gargantuan number over here, which they have to reduce. But if you know how to cross cancel or chop, you can simplify and get the reduced fraction very quickly. So that's a nice little trick to remember. Always cross cancel when you multiply fractions and watch those signs. All right, next example, decimals. Yeah. So here we've got 2 negatives multiplied together. The result will be positive. Now again, when I multiply 0.02, that's 2 100ths. Because decimal place wise, 1 place over is tenths, 2 places is hundredths, thousandths, and so forth. So this is 2 100ths times 12 times 3 100ths. So what I want to do here, I just go ahead and move the decimal over. I treat this like it's a 2 times 12 is 24 times 3. Which is going to give me 72. And then I worry about the decimal. So if I were multiplying hundredths times hundredths, I would have to move the decimal 1, 2, 3, 4 over. So in my answer, I'm going to move the decimal 4 places over. And I would get 72, and that would be 0.0072 for the final answer. So hundredths times hundredths would give me 10 thousandths, and that's what this is saying, 72 10,000ths in decimal form. So go ahead and treat those decimals like whole numbers. Go ahead and move that decimal place over, get them out of your way, and just multiply them like numbers, and then deal with that decimal only once. All right. Now on the fraction example here, get out the Ginsu knives or whatever and cross cancel and chop. So here we can take, before we go chopping also, be careful of your signs here. This is going to be a positive result. So when we cross cancel, we're going to have 3 into 9. 3 goes into 3 once, into 9 3 times. What else cross cancels? The 4 goes into the 12 3 times. And then you could also put a 1 under the 12, remember, to make sure those fractions line up for you. And then we can, is there anything else we can cross cancel across the top or bottom? Yes, there is. Look at those 3's again. So you can, again, if you cross cancel or chop all of the common factors, you will end up with a reduced answer when you do the fractions in terms of multiplication. So look how nice this one comes out. 1 times 1 times 1 times 1, 1. 1 times 1 times 1 times 2, 2. Positive 1/2 for your answer. All right. And one more decimale, as I like to call them, just to go ahead and get these decimals straight. So again, let's go ahead and multiply these out. Now in this case, we've got an odd number of negatives, so we're going to have a negative answer. And again, I'm going to treat these like whole numbers. So this is 5 times 4 is 20. 20 times 5 is 100. Times 70 is going to be 70 times 100 would be a 70 with 3. Well, let me try that again. Scratch that. 70 times 100 would be a 70 and 2 zeros. I'm running out of paper here. All right. So now let's go back and put the decimals in the answer. So we had to move this to make it a 5 3 places. Didn't have to mess with that number. 4 places. So the answer would be 0.7. Negative 0.7. Okay. So decimals, fractions, do not worry about them. Just, cross cancel, make these regular numbers. Life is nice. Life is nice. All right, next thing we want to talk about is the definition of division. The definition of division, and what it says is if you divide two things, anything written in terms of division can be rewritten in terms of multiplication. So A divided by B can be rewritten as A times 1 over B. And I think the easiest illustration of all the examples I have laid out for you is this one right here, 4 divided by 2, which we all know is 2. But we could also rewrite this division using the definition of division as 4 times the reciprocal of 2, which is 1/2. So really, when you divide something, you're multiplying by the reciprocal. And notice that 4 times 1/2, if you want to make that a fraction, you can do the chop there, and you will still get 2. 2 over 1 or 2. right? So in some of your algebra books, you'll see them wanting you to take these division problems and rewrite them in terms of multiplication. So we'll do that. So 9 divided by -7 would be 9 times the reciprocal of -7 is still negative, -1/7. 5 divided by x would be 5 times the reciprocal of x, which would be 1/x. And this rule is so important because when we get to dividing fractions, that's why you can't divide fractions. You can only write them in terms of multiplication using this definition of division. So we would say that 3/4 divided by -1/2 is 3/4 times the reciprocal, which would be times -2/1. And then you can go ahead and get your answer here. That's going to come out negative because you have an even number or an odd number here, you're multiplying by. And then you can chop, chop, two. So 2 goes into 2 once, into 4 twice. Final answer, -3/2. So the definition of division tells us that to divide fractions, you must multiply by the reciprocal. Or anything written in terms of division can be rewritten in terms of multiplication. We will come back to this later. All right, next, let's go back to some graphics. We want to start talking about basic properties of real numbers. Now that we've got your signs in order, once you can add, subtract, multiply, and divide using the real numbers, it's going to be important that you take this knowledge, this empowerment of the signs, and be able to apply it now to some general rules in algebra. And a lot of them are really common sense. I think when we look at some of these, you'll be able to understand the property simply by its name. Now, there might be a few that you don't, but we'll check it out. So going back to the graphic here, the first thing we want to refresh your memory on is algebraic terms are separated by plus or minus signs. All right, so remember, terms are always separated by plus or minus signs. The commutative property for addition and multiplication says this, the concept. We can change the order when adding or multiplying without affecting the answer. All right, so let's go to some examples of that. So the commutative property, and this is kind of a no-brainer, says 3 plus 2 can also be written as 2 plus 3. You're going to get 5 either way you look at it. All right? Or you could say 6 times 7 is going to equal 7 times 6. It does not matter which way you add or which way you multiply using the commutative property. Variables, you ask? We could say that A times B, AB, equals, using commutative, B times A. Or we could also say that 6 times x times y, and we'll put parentheses around the x times y, could be written a couple different ways using commutative. We could write x times y times 6, showing commutative taking this quantity and flipping them around. And if you think about it, commute, if you're commuting somewhere, going back and forth means you're going somewhere and coming back. It just means you can flip these around. Or you could also say, just flipping this one around, 6 times y times x. All right, so several different illustrations using the commutative property. All right, next we're going to talk about, looking at the graphic here, the associative property. Okay, the associative property of addition and multiplication says numbers can be grouped in any manner for addition or multiplication. Unlike the commutative property, the order of the terms stay the same. So let's look at some examples of that. So on the associative property here, let's start out real basic. I think we would all know this. 1 plus 2 plus 3 equals 1 plus 2 plus 3. Go figure. All right, now what associative says is it doesn't matter which ones you add together first. If you add the 1 plus the 2 together and then the 3, you're going to get 6. Or if you add the 2 plus 3 together and add the 1, you're going to get 6 as well. Works for multiplication. You could say that A times B times C, using associative, equals A times B times C. Now notice the terms are staying the same. The A, B, C order here. The only thing that is changing is how we group when we multiply. So sometimes students will confuse the commutative and associative properties. Just remember, associative always stays in the same order. The terms do. Okay. Next, let's go back to a graphic. All right, now this is one of the most important properties in all of algebra. I would say the distributive property, the highest property of all. And the first concept of that is anything outside of parentheses gets multiplied or distributed through the inside terms of the parentheses. Okay, so going to some examples of this distributive property, notice I've got concept 1 here, distributive property over addition. A times B plus C. All right, so what we're going to do is we're going to multiply A times B and then A times C. So everything outside the parentheses gets multiplied through. So how do we write A times B from previous lessons? Well, the easiest, laziest way to write it is AB. Plus A times C is AC. Now you could put the dots or parentheses around these or so forth, but that's the generally accepted way. The distributive property over subtraction, same principle. You're taking the A and running it through the parentheses, multiplying each term by A, and this would give us a result of AB minus AC. So some quick examples here with the distributive property. 9 times x minus 2, 9 times x is 9x, minus 9 times 2 is 18. Fractions, decimals, oh, you know we're going to have them. We're going to keep those fundamentals straight. 3/4 times y plus 8, 3/4 times y is 3/4 y plus, if you have to write it out, you can. If this bothers you a little bit, sometimes students will get confused with the fraction, so we'll write 3/4 times 8, and we'll go ahead and make the 8 over 1 here. And you know what we're going to do with these? Yeah, we're going to cross cancel the 4 and the 8. 4 goes into 4 once and into 8 twice. So our final answer then would be 3/4 y plus 6. 3/4 y plus 6. And finally, distributing the decimal, which you can do all through this one here. We'll go ahead and take it one term at a time. 0.7 times 2a, again, just act like this is a whole number here. 7 times 2 is 14a, right? Where's the decimal go? Well, since that's 7/10, we want to move the decimal one place over, 1.4a. Plus 0.7 times 5b. 0.7 times 5, that's going to, 7 times 5 would give us 35, so this would be 3.5b. And then the 0.7 times the negative 3 there is going to give us a negative 2.1c. Okay, so the distributive property, very, very important. So we can multiply things outside parentheses through in various manners. Now let's go to the next graphic. All right, concept 2. Now this is sometimes scare students. Any terms with something in common can be undistributed or factored out. Okay, and some examples here, we've got 4x plus 4y here. Let me bring my magic hand here into place. I'm trying to bring my magic hand into place. Here he is. 4x plus 4y plus 4z. Notice there's a common 4 we can take out, and when we take it out, we're left with x plus y plus z. So we're undistributing. All right, the second example here, ab plus ac plus ad equals, you can take the a out and notice what's left. All right, so looking at some more examples here, the distributive property, which another word for it is called factoring. To factor, 1, you want to take out the greatest common factor first. Put the greatest common factor as the first part of the answer. 2, divide each term by that greatest common factor and put what's left in the parentheses. All right, so we'll look at some examples of that real quick. 9x minus 27, I think we can see what's in common. The largest number that goes into either one of these two terms or comes out would be 9. So once you see that greatest common factor, you can take it and divide each term by that common factor, and that will leave you with the answer 9 times x minus 3. So instead of multiplying the 9 through, we're factoring or taking it out and undistributing. The next example, AB minus AC plus AY. I think everyone can see there's a common A there, which if you work hard in the course, that's the final grade we're after, except capital A on that report card. And that gives us B minus C plus Y. Notice my signs in here are not changing or deviating. Now on this third example, this last one here, there's a common 7, or some students might look at this and say, well, Young, I want to take a negative 7 out of here. Does it matter if I'm factoring? Well, the answer is no. I mean, we could take a positive 7 out of this, and that would leave us with, if we divided each term by a positive 7, negative 2x plus 3y plus 1. Or if some student wanted to take out a negative 7 and put that as the first part of the answer, we can just change these signs here. So we notice we've got some of our multiplication and division sign rules working here. That would leave us with a positive 2x, negative divided by a negative, minus 3y, minus 1. And we could multiply this back through and check it, which we'll talk about in a second. Ta-da, here it is. To check factoring, multiply or distribute that greatest common factor back through your parentheses. Make sure there are no common factors left in any of the parentheses. All right, so what I mean by that, sometimes I get a problem like this, 48x plus 120, and I'll ask students to factor that. And they'll go, wow, Young, there's all kind of numbers that go into that 48x plus 120. You could take a 2 out. You could take a 4 out of each term. You could take a 6 out of each term. You could take a 12 out of each term, and maybe even more. How do I know? Well, let's say that you saw a 12, which some of you might have saw the numbers before that. I'll show you how you can check and make sure you get this. If we take a 12 out and divide each term by 12, we'll end up with 4x plus 10. Now, does this check according to our rules up here? Well, if I distribute or multiply the 12 back through, yeah, that gets me back here. But in my second step to check, hey, there's still something else in common that I can take out of here. And that is, I think everyone sees, is a 2, so I missed it. So if you don't get the greatest common factor, you can tell because there'll still be something left in common here, and you can go, oh, rats. All right, so we'll take that 2 back out and put it out front here. So we'll end up with the correct answer. 24 should have been the greatest common factor. 24 times 2x plus 5. And that will follow both directions here. So if I multiply the 24 back through, it will check, and I know it's correct because there's nothing else left in common here. Okay. So one additional property we want to talk about before we get off today is the identity property for addition, and that's on the next graphic. Let's look at those real quick. So anything plus itself equals 0 is the identity for addition. And the identity for multiplication, anything multiplied by itself is 1. So to look at some quick examples here, if we say 5 plus 0, we get 5, identity for addition. On multiplication, 5 times 1 equals 5. All right, and we'll come back and do some more in the next set. So in closing, now that you have the algebra concepts within your grasp, you know what to do. Math is like a bank. What you put in or deposit, you can withdraw come test time. What you don't put in, you won't get out. Think about it. Take care. We'll see you next time.